All right, so now we're going to start talking about lines of longitude, latitude, how they work together in hemispheres. Lines of longitude, or meridians, and I'll write that down for you here, circle the Earth from pole to pole. So here's your North Pole, here's your South Pole, and these lines are going to touch both. One way I remember lines of longitude is I think of hairs being long and it runs up and down. These lines measure the distance between east and west. And the starting line is going to be right here, which is your prime meridian. This is 0 degrees longitude. And this place is found at the Royal Observatory in Greenwich, England. So anything that is this side of the prime meridian is going to be measured in east. Anything this side will be measured in west. So for example, we have 90 degrees west, and then we have 90 degrees east over here. All right, next we have lines of latitude. These are imaginary lines that measure north and south distances. These latitude lines are also called parallels. And they run parallel in an east and west direction, north and south of the equator. Now the equator is going to be 0 degrees latitude. And one way I remember lines of latitude is I think of flatitude. These lines are completely flat. Now they measure degrees in north or south. So here again we have your equator right here. Okay, so anything north of the equator is going to be measured in degrees north, and anything south of the equator will be measured in degrees south. For instance, this would be 75 degrees north. This would be 45 degrees south. And how they work together. The grid system formed by the lines of latitude and longitude make it possible to find the absolute location of a place. And remember, we went over absolute location when we talked about the 5 themes of geography. Only one place can be found at the point where a specific line of latitude crosses a specific line of longitude. By using degrees, people can pinpoint the precise spot where one line of latitude crosses one line of longitude, also known as an absolute location. All right, so just to review here, this is the prime meridian. Here is your equator. These are lines of longitude because they are long like hair. And then we have your latitude because they are flat. All right, now we are going to talk about hemispheres. Hemisphere is a term that means half the globe. It can be divided into northern and southern, or east and western hemispheres. Okay, so now we're going to have the equator. Oops. Equator and the prime meridian come back into play again when we talk about hemispheres. So we have the the northern and southern hemispheres, which is divided in half by the equator. Now you have your western and eastern hemispheres, which is divided by the prime meridian. All right, now we are going to talk about projections, and these are basically projections of the Earth, which is round or globe, on a flat map. The most accurate way to depict the Earth is in a globe, a round scale model of the Earth. A globe gives a true picture of the continents, relative sizes, and the shapes of land masses and body waters. Globes accurately represent distance and direction. A map is a flat drawing of all or part of the Earth's surface. Unlike globes, maps can show only small areas in great detail. Maps can also display political boundaries, population densities, or even voting returns. So basically, to take something that is supposed to be circular, like the globe, like Earth, and then try to flatten it on a map, you're going to have some distortions, which means some of your information is going to be wrong, and that's why we have different map projections. I'm going to go over this very quickly. I would just like you to be familiar with what each projection looks like. So you have the Mercator. The Mercator projection shows most of the continents as they look on the globe, but the projection stretches out the lands near the North and South Pole, so the land is going to look bigger. The Homogeneous projection shows accurate shapes and sizes of land masses, but the distance on the map is not correct, and it has this kind of funky M shape looking thing. The azimuthal projection shows the Earth so it is a straight line from the central point to any other point on the map, and it gives the shortest distance between the 2 points. The Robinson projection, this is usually used in textbooks, and it shows the entire Earth with nearly the true sizes and shapes of all the continents and oceans. However, the shapes of the landforms near the poles appear flat. All right, pay more attention to the longitude, latitude, and hemispheres. I just want you to be familiar with the projections. You don't have to know them in great detail. If you have any questions, write them down, and have a good night.